Section 6.2, example 4, graphing the stretch of an exponential function. So sketch the graph of f of x is equal to 4 times 1 over 2x. State the domain, range, and asymptote. So here we don't have any shifts, we just have that stretch. So we could use our normal 5 to start graphing. So the normal 5 are going to be our -2, -1, 0, 1, and 2. And let's see what the rest of our function is. So here we have 4 times 1 over 2, and we're raising that to the power, we're starting off with -2. And that's 16. Exact same thing. This time to the power of -1. 8 to the power of actually 0 is 4 to the power 1 is 2 and to the power 2. That's 1. Ooh, okay, let's see what happens to this. We might need a couple more, but we'll see what we have. Let's bring it down a little bit more. Let's say 2, 4, 6, 8, 10, 12, 14, 16. All right, and starting off with -2, 1, 2. We're up here at 16. -1, we're at 8. -4 or 0, we're at 4. 1, we're at 2. 2, we're at 1. So it looks like the graph, again, as we start picking bigger and bigger numbers, our vertical asymptote or horizontal asymptote is still going to be at y = 0. But that stretch forced us to go up a little bit. Like forced the graph to kind of shift in a way. But let's see if we could explain how that happened. Let's look at our domain first. Our range and our asymptote. Domain for all of these are going to be -infinity to infinity, all real numbers. The range for this one, we get closer and closer to 0, but never actually touch it. So we could look at our asymptote for that one. Y = 0, and we go from 0 to infinity. But let's do a little bit of manipulation with this and see if we could explain how it looked like we shifted a little bit. F of x is equal to 4 raised to the 1 over 2 raised to the power x. So 4 and 1/2 are both powers of 2. So we could actually look at that to see how we were shifting here. We could rewrite 4 as a power of 1/2. So let's look at the base first. So this is 2 squared, 1 over 2x. To make it 1/2, we could take it to the power of -1. 1/2 to the power of -2 is still going to be that 4. Now that we have two numbers of the same base, we could add the exponents together. So 1 over 2x minus 2. So we were able to rewrite this equation to kind of fit what the function was doing here. So we grabbed our regular 1/2 function, and instead of it looking like this, we actually shifted it to the right 2 units, as you could see right here. So that's kind of cool. If you have things of the same base, you could manipulate it in this way or just leave it as is, whichever is easiest for you. But I just kind of like seeing how the numbers play out like that. If you have any other additional questions, please feel free to ask. Otherwise, bye.